This is the final part in my oscilloscope tutorial trilogy. The first thing I want to talk about is triggers. What is a trigger? A trigger is a voltage threshold that the signal has to reach before it gets displayed on screen. Now let me give you an example. By default, your oscilloscope is probably set to automatically trigger on whatever looks like an interesting waveform. This works really well for repetitive signals like the sinusoid I'm viewing here. But what if I'm trying to observe serial data? Serial data can come and go in the blink of an eye. If someone types a character on a terminal, that character will get transmitted in about a millisecond, and unless you have the right trigger settings, you might miss it. Now let's try that again with some different trigger settings. Here I have my oscilloscope probe stuck right into the transmit pin of an RS-232 port. Whenever I type a character on hyperterminal, I want the raw bits to get captured and displayed on screen. If I go into the trigger menu, I can see some options for slope and mode that I want to change. Changing the slope means that I can set the trigger to fire on a rising edge, meaning a transition from a low voltage to a high voltage, or a falling edge, meaning a high voltage going down to a lower voltage. With the mode setting, auto mode is good for repetitive signals, but since we're looking at serial data, we want to use the single setting. This will allow us to capture a single waveform and keep it static on screen. Also, the trigger level knob over here will let me set the trigger threshold, so that when the voltage goes beyond a certain level, the trigger fires and the signal is captured. I'm going to set the trigger to 1 volt now. Alright, let's try this again. Excellent. Now I can clearly see the ones and zeros on screen, and if you can read binary, you can verify that the correct data is being transmitted. Now this may not seem so useful when I'm using a PC with hyperterminal and I already know what key I'm typing, but if you're designing something without a screen, this becomes important. The last topic is 2-channel mode and math functions. I can enable the second oscilloscope channel just by going to its menu and turning it on. You can change the volts per division setting of the second channel independently to the first channel. This can let you view the DC and AC parts of a signal at the same time. You can also do fun stuff with the math menu. You can add voltages together or subtract them and get the result displayed as a waveform on screen. Let's say you want to measure the difference between two voltages in a circuit. You can use the subtract function to accomplish this. If there's a voltage difference where there shouldn't be one, you might have something wrong in your circuit board. Well, that's the end of the tutorial. Chances are by now you know more about oscilloscopes than your teacher. Have fun!